As I said, I hope lunch was successful. Keep your tummy full for tonight's drinking. It's a health and safety notice. All right, let's kick things off. I'm Ian, and today we're going to talk about the nasty things that's written behind me. The focus of this presentation is data exfiltration. So I'm considering everyone owned already, which is probably not too far from the truth. And we're going to talk about how to get data out, which is, in my mind, a little more important than trying to get in. Some housekeeping. I'm not a CISSP. I'm not anonymous, although I kind of like the notion. Hacker, researcher, developer, really bad one, but got to try sometimes, I guess. I actually try to dabble a little bit and manage development for like 2 years, which is it's interesting. Didn't work out that well. Most of my research in the past years have been focused on cyber crime and cyber warfare, as Miko dubbed it before. Mostly from the non-technical part. I mean, the technical part is the stuff that we deal with on a daily basis and is fairly well covered. I was trying to get into more of the who's behind the scenes, who's paying who, how does the business process work, which was very interesting, but kind of led me to new things. I've set up the DEF CON group back in Tel Aviv in Israel, where I live. I'm part of the PTS founding something, the Penetration Testing Execution Standard. If you don't know what it is, get out, you're doing something wrong. And in my spare time after all of that, I do some reserve duty in the Israeli Air Force. So that's who I am. This is what we're going to talk about today. I'm going to cover some ground in terms of infiltration, breaking in. I'm going to talk a little bit about data targeting and data acquisition and kind of figuring out what to do once you're in and how to look for information. And then we're going to talk about the exfiltration, which is the really cool part. I'm okay with interruptions in the middle, and I really endorse it. So please, if you think I'm full of shit, if you think that there's something wrong up there, which I'm sure there is, please stop, yell, tell, bring drinks over here, whatever you see fit in this situation. So let's start with breaking in. Again, this part is going to be fairly quick because I just want to cover some basic elements. We're going to talk about technical stuff, human stuff, and command control. Okay, so let's start with some technicalities. Breaking in, the technical elements are pretty obvious. They're the exploits, the standard channels to try to use those exploits on the web, mail, FTP. But there are all those, protections and stuff around it, like firewalls and all those, yeah. But firewalls are built, behind the firewalls there are a lot of Windows machines and they have lots of software installed on it and more software. And then protection. How many exploits are there for AV products? Do you know? Shitloads, okay? And it's funny because they're going to be installed. It's not like a guess. Do they have Adobe? Do they have WinZip? Do they have WinRAR? They got to have some kind of AV. So the attack surface is actually not as small as we thought initially. All right, it's not just the mail over here and the web server over there and the FTP. It's all those client machines with all that crap installed on it, and it just keeps evolving and keeps enabling us to do stuff. So the attack side is again fairly easy to accomplish, and you have a lot of talks here, and you can find a lot of talks on the internet that discuss client-side exploitation, a lot of interesting tools that can do that for you. So let's move on to the more human side, because when you're talking about exploiting clients, you need to get a little more involved with the humans that operate them, as opposed to when exploiting just servers. One element is just, human as in pay up or your website gets down. But that's not what I was going for. I was going more for the, hey, this should be famous by now. Okay, anyone recognize the email? I can't see this shit. This is the 2011 recruitment plan email that was sent to RSA that someone pulled out of a spam folder to open the attachment and get owned in a network that had no segmentation. Okay, purely human. Okay, there's nothing technical about grabbing a few exploits for Office. It's an Excel file, and making sure that they can travel within the network. Purely human. You had someone to pull it out of the spam folder just because it was interesting. And all the rest of the phishing and kind of human enticement techniques to make sure that the stuff that we sent to our testees, wow, that sounds almost dirty, actually works. There are other elements, a little more physical ones, such as the USB keys that you get handed out here, which surprisingly, kudos to ESET, or whatever they're called, had nothing on them. They're usually either infected or have loads of marketing crap. So these things are extremely popular and extremely intriguing when you provide a USB key to someone. Not like here when I hand stuff over or you pick stuff from the counters, but you find something in an interesting location, you can be almost 100% sure that it's gonna get stuck in somewhere. Dirty minds. So just leave it in a location that's gonna have people think and kind of get them intrigued, and something's gonna happen. Okay, and armorizing or weaponizing one of these is fairly simple. On top of that, everything that I talked about can mostly be automated with tools like SET, which is just phenomenal. You can just pack all of that stuff, stick in a USB key, generate it, and you're off. As long as you can follow instructions and kind of fill in the numbers by the menus. So that kind of helps. Last but not least, it helps when you need to interact with people to kind of assume someone's persona, either down low or as a technician or as a delivery boy. I pick up smoking. I mean, I'm not smoking on a daily basis, but I do keep the ability to smoke without choking on myself, just for those reasons. To be able to walk out to a smoking area like here, socialize a little bit, grab a cigarette or two, and then walk back in with the guys or the girls or whatever it is. And it really helps sometimes to hire people that will distract or create some kind of confusion with the audience that you're trying to manipulate. Okay, go to Dale's talk. He's gonna probably mention that confusion element that you can abuse. Let's move on to command control, which is important, just as important in infiltration situations. Just one note on command control. When you try to get into a secure network, such as the ones that we're going to try to exfiltrate data from, you have to take into account that in most cases, you're not going to be able to communicate directly with your payload. Okay, it's going to be segmented. It's going to be behind a few layers of separation. So just as other or modern malware does, you have to take into account that your command control structure will probably be layered as well. So these things are starting to be built into modern attack tools. And we're basically looking at a lateral communication mechanism when you reach the actual target, and then some form of kind of upward bubbling command control structure. Non-interactive in most cases, so you're not going to have like fancy interpreter shells where you can type in commands and communicate with your target, but more in terms of, all right, So here's what I want you to do. 1, 2, 3, 4, 5. Look for those files, look for those networks, off you go. Okay? And then starts the real interesting, or the game of patience, as I like to call it, starts when you just leave it off and hope for the best. And because you're not going to get any feedback until something triggers something else. So wrapping up the breaking in stuff, we'll talk a little about targeting, and we'll talk about precision targeting and some APTs. How do you get, or how do you decide who to attack? All right, you have a big corporation. We said that the mail and the FTP and the web servers are out of the question because they're too hard and they're too well protected, except for the web server ones. So you start digging out information. A lot of targets will voluntarily provide information on themselves. Tools like FOCA, tools like Multigo will help you get that information in a structured manner and gather as much data, as much as preemptive data on your target as possible. You'll get names, job functions, email structure in terms of how they build their email addresses, social connectivity, and on top of that initial list of targets, you should start building extra layers. And those layers are usually built from social networks. Okay? Everyone uses them today. There used to be a time, like a year or a couple of years ago, when companies started saying, oh, no, we can't have social media inside the network. Gone. I don't know any company right now, big, small, defense contractor, government, whatever it is, that does not allow some form of social media. So that's very popular. And again, map everything on top of it and go beyond the usual suspects. Okay? You'll find stuff that's much more interesting in the second and third degrees of connectivity that enable you to get much more assured access to your assets. Okay? So instead of targeting this individual, I'm going to target that individual. Okay, who's not even working for the company, but he's connected to this guy, and he's also connected to 2 other individuals in the company, and he's bridging over to some other community here that is a second or a third degree of connectivity from my target, and this guy's not even an employee, all right? And he's much more open in communicating, and he's associated with different technologies and tone and way of communicating, okay? And he may not be as well protected as the other guys. So I can make him, I can either attack him and make him send messages that my targets would click, and those are the targets that I'm going to look out for, okay? And this is actual mapping from one of the engagements that we've done. Everything that you've seen here that's not colored yellow are the bridges, are the interesting social connections that can be linked into the company that we're trying to get into, and we're just color coding them in terms of communities and the kind of tone of communication that you use publicly and privately and in different forums, so we can get a better map of, all right, so this is how we can get in. So take that into account when you do targeting. Then you need to craft your payload. All right, we talked about the payload before. This is going to be really quick. We're using standard stuff. Okay, there's no point of reinventing the wheel. There's no point of writing custom malware, Trojan, Bundes, whatever. Just use the off-the-shelf stuff. Most of the stuff works and can be weaponized to bypass standard AVs. All right, we're seeing screenshots here from Zeus, SpyEye, and Limbo. They used to cost a lot of money. They still do, kind of. If you go to the forums and try to buy one with a license and with support and whatever modules they offer. But at this point, with all the data leaks and all the release code that's been out there, you can probably get them for free if you're resourceful enough. Okay, so just use that. Make sure that the code that you're reading is clean. Do some code review on it. You'll find some very interesting stuff. Once you get that, you want to turn it into an APT. There, I've said it. I've joined the, yeah. Now, the real difference between the off-the-shelf, let's say Zeus or SpyEye binary that you'll generate and an APT is very simple. First, detection rate, okay? That can mostly be taken care of with correct packing. Okay? Most commercial packers will enable you to bypass AVs just by a click. Okay? And you can buy them. Again, you can have more sophisticated ones that actually test against local versions of AV that won't send the tested files back to VirusTotal or something like that, or the vendors. And then make sure that your payload also knows what to look for. Again, remember that we're talking about asynchronous communications. You're not going to have a lot of chances to instruct your payload, go here, go there. So make sure that in your intel gathering, you've gathered enough information to tell your Trojan, all right, this is what I want. File servers, databases, maybe you already have some names of internal systems. So make sure that they're focused on where the money is. Last but not least, APT versus standard. The real difference is patience, okay? No updates for an APT versus daily, sometimes even hourly updates for the traditional stuff. And the reason is simple, exposure. This, a traditional banker Trojan will be massively distributed. Sorry, will be distributed massively. Trying to get as many clients as possible, as many infections as possible. In our situation, you're talking about 4, 5, 6 targets that will get that actual binary. So your exposure is completely different. On top of that, you know that you're not going to be able to update that. So taking that into account, your visibility goes to almost 0. And again, it's mostly patience. The criminals can allow themselves to keep pushing updates and keep pushing new versions and changing the configs and updating the way that the Trojan interacts with a banking website. You don't have that privilege, okay? Or if you're a target, you're not going to have that privilege of seeing a lot of communication in terms of the malware itself. The fun part, exfiltration. We're going to talk about avoiding data leakage prevention systems. They don't prevent much, but they try. We're going to talk about detection and prevention in terms of IDSs and IPSs, encryption, and archiving. These are the key elements when you're talking about data exfiltration. Let's start with a little detection and prevention. How does an IDS work? Quickly. Anyone? IDS, what? Excellent. It looks for signatures, okay? It looks for patterns that are easy to recognize. It needs to be efficient and fast. Same goes for IPS. Just trying to get as much recognition as possible. So our problem would probably be to avoid using those patterns. How do you do that? You encrypt, okay? Most IDSs and IPSs are completely blind by definition when it comes to encrypted protocols, unless there's some kind of SSL termination facility that stops the web traffic, decrypts it, inspects it, and then re-encrypts it when it goes out. It's blind. So just encrypt your stuff, either over SSL or by yourself, which is usually better. Remember that SSL might be terminated, but this cannot. You know what this is, right? It's obvious, can't you see? But there's still a problem with what you're seeing here. All right, if I have, my secret document that I managed to grab from the network, and I try to encrypt it like this and send it out, can I still detect it using DLP or IDS or IPS? Yes? No? Yes, there is a question on entropy, which is interesting. Remind me that in a couple of minutes when we talk about Duku, okay? But there's still crap here that's easily detectable, all right? Still signaturable. So we take the crap out and leave just the encrypted stuff. And you can play around with this a little bit. This is still, if I would give this to you, you'd say, yeah, that looks kind of familiar, right? There's this equal like at the end, so it's kind of, you'll figure that it's something interesting. So just go stupid on it. Okay, XOR it. Put something really, really dumb, but it's fine because this is not a competition. Okay, this is your algorithm. You know what you're doing. It's not like you have to win some, fancy prize on encryption. It just has to work. Okay, so if I'm able to still detect, or if this still raises some flags in terms of entropy or something like that, just mix it up with something. Right? Make sure that it's more spread, less spread. As long as you know the algorithm to unscramble it, you're fine, because you know what you need to do on the other side. And using those techniques, very, very simple techniques, you can get to 0% detection rate on any fancy DLP vendor that sells their stuff for hundreds of thousands of dollars. Sorry. And then you need to push it out. Okay? And the simple stuff still works. Right? All of those techniques that you're seeing here are bulletproof in my mind. And the social media stuff is just obvious, and there's been a lot of research done on command control channels using Twitter and Facebook posts, and you can just use it all the same. Dropbox have very easy to use APIs that you can arm your payload to use and just upload files. Okay, encrypted, non-encrypted, it uses SSL by default. DNS tunneling, again, it's classic. As you guys remember Aurora from a long time ago? Anyone remember what's the reason or what helped Google detect Aurora in the first place? Come on. It was just Swedish balls down that you ate. It's not that heavy. DNS logging. All right, Google detected Aurora and tracked it down because it was logging all DNS requests. Okay, that's what enabled them to figure out, oh, there's some anomaly here. Someone's making too many requests. Let's look at what's going on. But DNS is very useful for kind of poking holes and pushing data out. The two interesting ones here, the blogs and the wikis, I'd like to expand a little more on. Blogs are, again, obvious. You can just post data on comments, all right? Where you find blogs with open comments that do not require moderation. You can create your own blogs and just post the data onto posts, okay? And remember, again, we're posting the encrypted information. So as some homework, interesting stuff, go to blogger.com, blog post, whatever, all those free blogging platforms, and try to look for blogs that have absolutely no meaning in their postings. You'll find some really, really weird shit. And I'm not talking, some obscure Swiss German language blogs that are almost encrypted. I'm talking about really, really this is not a language, characters and characters of crap. And what you're looking at are back channels used by all sorts of people, shady and shadier and shady less, that use that public platform anonymously with phenomenal uptime to communicate between themselves. Okay? Smart. My favorite one, wiki. Wikipedia. Find some page on Wikipedia. And I know that you're probably thinking, oh, so create another page and post the data onto. Almost. When you create pages or change the content of pages, it gets moderated, and there's a whole, and stuff can be taken down in a matter of hours. I've seen that. But there's a funky feature of wikis, media wiki specifically, and Wikipedia, that behind every page, something else is happening. Anyone knows? Commentary, exactly. The talk page. Okay? Now, the talk page by default is not presented. You have to go into it and look what's going on. So find some obscure definition of, I don't know, the history of Switzerland, okay? Where there's not going to be a lot of argument and discussion on. Okay, sorry. The history of the Middle East, I can one-up that. It's a Phillips screwdriver, okay? It's not going to change. It's going to stay like this. And make your payload post data into the talk page. It's not going to show up on any crawlers or indexers or anything like that. You know where it's going to post stuff, so you just monitor that talk page, and it's just going to start showing up. Encrypted, it might take days, sometimes weeks, sometimes never, for someone to realize that, someone's messing with the talk page of some obscure definition. Let's clean it up. And that stuff usually doesn't get cleaned up. Okay, so that's a very useful command control, like general channel, both for command control and definitely for exfiltration. Quick comment about Duku. Do you know how the exfiltration was done in Duku? Anyone? Where's Miko? Come on. Oh, he's on the flight already. Duku is interesting because it actually used exfiltration. It actually, as opposed to Stuxnet, which just blew shit up, it exfiltrated the data. And it was like someone was sitting throughout the first half of this presentation. It's like, oh, okay. What they did, they took an image, a standard JPEG image of some, space nebula, whatever, and just appended just basic steganography. Okay, hard to detect using automated means, definitely DLP and IPSs, and just appended stuff on top of it and shipped it out through web posts. Simple. But what happens when they cut the cord? And they're telling you, great, but you don't have 80, 443, 53. What do you do then? You're still in. You manage to get a payload onto a very secure network, but you can't get out. Sounds like a song. Can get in, but it can't get out. Well, one way is you can print your shit. Okay? So that encrypted blob of text, find a printer, as we said before, and just print it. Anyone recognize what this looks like? Anyone sat on the printer talk before? What happens when the PCL, JPL gets screwed up? What does the printer do? No one's ever had that? Installing, driver problems on HP printers. It starts printing pages. You print like one web page and it starts printing like 20 pages of garbage, okay? What happens to those printed pages? Yeah, you throw them away. You throw them away and they get treated differently for some reason, okay? Because when I print, if I would print the actual top secret document, okay, in a company, it would probably get shredded because someone's going to pass by the printer and it's like, oh shit, no one picked it up. I'll shred it. As opposed to this crap that always sits like in stacks beside the printer, either for reprinting or for recycling. Okay? That stuff doesn't get shredded. And if it doesn't get shredded, it ends up somewhere where I can probably reach it. And then I get my intern. This is, by the way, this is not my intern. This is the only Google image that you can find on dumpster diving, and everyone who's doing a talk that involves dumpster diving has that image, sorry. My intern wouldn't let me take a picture of him when he's dumpster diving. So you can get those printed pages, and then all you have to do is just kind of, make sure they're kind of straight, put them back on the scanner, OCR, and you have your data back. Okay? Let's talk about another method, and this is something that we've seen kind of, brewing up in the dark corners of the internet, and we actually used that several times. for some of our customers, the more security savvy customers. And this method basically takes data and transmits it using voice over IP. So here's how it goes. You get data, okay? You take a binary representation of whatever you want to send out and treat it, take half bytes. Again, this is for the proof of concept. It can be massively improved. A half byte can have 16 different values, right? Simple math. You take those values and you map them to 16 different octaves on the human audible range, okay? You take those octaves and you record them and you generate a VoIP over IP call. Yes, it's a new protocol. I put VoIP on your VoIP, so and you generate the voice over IP protocol. Most networks that we've dealt with claim to have some kind of separation between the voice over IP network and the local area network, but there's always someone, some asshole that's got to have the Cisco VoIP, soft phone installed because they need to be accessible here and they need to VPN in and whatever. So there's always going to be some kind of overlap. So it's easy to get to the VoIP network, all right? Too easy in my mind. And once you're close enough to the voice over IP network, just generating, spoofing a call or writing over someone else's call is fairly easy and again, can be fairly well automated. There's a lot of tools to do that. So you generate a call and you dial some number outside the company. And that number, again, is switched somewhere, let's say to a Google Voice account, and you just leave a message. Now, you basically have a message composed of tones that are one of 16 octaves, let's say in this case, half a second in length. They just play out consecutively. And all you have to do now is pull that data from your voicemail, run a fast Fourier transform on the voicemail, and translate those 16 octaves back to half byte values, reassemble the data, and you're done. You've got the data out. Simple exfiltration. Here's how it works. We actually built a very simple Python script that takes a file called message.txt. Again, this is a proof of concept. It's very simplified. It is not meant to be used. You can't use it in the real world, okay? You need to really improve it. I can sell you the improved version if you want. So you take it as an input and ask it to produce a sound.wave file. Okay, so it takes it, half bytes, 16 octaves, and generates sound.wave. And then use a SIP client and you have the file, okay? Just use a SIP client, make that call, and that's what you get on the voicemail. Okay, I have your data. All you have to do now is go to Google Voice. Well, obviously you got an email, you have a new message. Download the MP3, convert it to WAV because I'm too lazy to figure out how to use Python for MP3s. Convert it back. This is the other script that uses the fast Fourier transform to identify the 16 different ones. By the way, there's a long, 2-second preamble at the beginning, just for synchronization and kind of getting the first tone, so you can adjust the other 15. And it generates a file, output.file. In our case, it's an actual ASCII file. And lo and behold, the data is out. Super secure network, no internet, no nothing. Even the voice over IP network is not SIP connected to a trunk. It's got a PSTN line coming in. Okay, so nothing. We had to do this twice, by the way, because the client wouldn't believe that we got the data out. I'm like, look, I got it. It's not like I broke into your fucking facility because it's guarded like Fort Knox. I got the file. It's like, no, it's okay. We'll do it again. And the first time I heard that on my voicemail, I was like, I was beyond. I mean, there isn't a language that can explain sexual arousement as well as what I had when I heard that. And my wife was like, "What the fuck's going on?" I was like, "Honey, listen, it's it's like good for you. Keep playing with your computers." Yeah, it's like, no, you don't understand. It's sorry, geeks. So that's that's one way another way, sorry, to exfiltrate data. Now, I did mention that I do love those things. All right, HP, Xerox, thank you. You keep me employed and entertained. And another reason why these things are so phenomenal, and again, if you watch the previous talk, you already know how fucked up they are, is that they're really connected to a lot of obscure things. One of them is fax. That thing can receive and send faxes. Okay? Or if it can't, there's probably some other mail to fax or some facility inside the organization that can send out faxes. So why not send the data out using what you were given? Okay? If you can get a company to send you a fax, a lot of times the header, the top line that gets printed when on the fax that you receive, will contain some information on who sent the fax. A lot of times it would have something like this, which is the mail address to which the fax was sent to internally. All right? Or the mail address of who sent it internally, and then some appended, dot fax server dot int company, whatever. Okay? So it's fairly easy to figure out where the printer is, where the fax server is, and tell your payload to just send an internal email message to that facility. DLP is probably not going to look at it, all right, because it's part of the data paths that are supposed to happen. The friendly fax server and the printer will actually take any document or most documents that you'll give them and convert them visually to something that they can fax. So Word documents, PowerPoint documents, Excel files, PDFs, fax away. All you have to do is open up a new Gmail or Yahoo account, sign up to one of those free fax services that you get on the internet. You get a number that you can receive faxes to for free. It's only if you want to send faxes that you have to pay. So easy. And there you go. You have your data out. Some conclusions before I completely run out of time. We'll cover some of the controls that you're maybe able to use or should be able to use for data leakage, for exfiltration, sorry. We're going to talk about data path mapping, okay, and how that works and how that can be used for you, okay, to protect yourself against those kind of things. And we'll talk about mapping and kind of figuring out where stuff lives. So let's start with controls. I'm sorry to disappoint you. There is no vendor in the world, and would never be, that would sell you a solution that would fix your problems. By the way, there never was, okay, to any of your security problems. So there's no point of running out here and trying to browse the internet and look for vendors that will solve this or whatever other problem. You have to start with a human factor, right? And that's the reason I also covered the human factor at the infiltration part. So start with the human factors and then figure out what technology can help you mitigate that, okay? Because you can build the most secure network in the world and no one's going to be ever able to penetrate it. But the first user that you introduce into that network fucks up your entire security mechanisms, okay? I hope this is like a given. I'm not telling you anything new. And then enter technology, all right? So figure out who's doing what, find a technical solution to solve it, all right? By the way, this is the most secure printer in the world. It's called a Shrinter, and it's available on ThinkGeek. You have to figure out where your data lives, okay, and how it moves. What's the life cycle of your data? To do that, you need to spend time with people. I know, scary thought. People from your own company, not geeks like here. This is cheating. You have to spend time with developers. You have to spend time with marketers. you, I know, managers, everyone, okay? Project managers, love them. Um, because that's the only way that you'll be able to really understand what's going on in your organization. It is not built on technology. I know, shocking. It's built on people doing stuff. And you'll often find that the stuff that was supposed to happen in your little diagram of this is how stuff happens and this is how my company makes money is often a little different than how stuff gets done in the real world. Because people will tell you, oh yeah, I know that there's a procedure, but we've been doing this for 20 years now and it's worked perfectly. Okay, so you've built all this technology here to support, but someone's doing this with like a clipboard. And it works, okay? So map out how the data flows inside. Sit with developers. You'll find stuff that will make your eyes bleed. It's just, sometimes it's phenomenal. Hack the business process, okay? Figure out how things operate. How does the company make money? And then you'll find all those little loopholes that if I were an attacker, I would exploit. And again, I wouldn't go for your firewalls and fancy IDSs. I'd go for the people. I'd go for the weak processes. I'd go for that obscure server that sits on the second floor of accounting that does the accounting magic that no one touches because it's not supported. And map your stuff. Again, get 5 network engineers to sit in the same room and tell each one of them to draw the network as they think it looks like. Okay? You will start the geek fight of the century when they'll find out that everyone thinks the network looks differently. And you'll find new networks, new servers, new connections to God knows where, because no one really knows what's going on. Everyone's got a perception of something, and until they actually saw it, until they actually go out and touch the things and say, this is 1, this is 2, this is 3, that's how they're connected, no one really knows what the connectivity looks like. Funny story, I was investigating a potential data breach for someone, let's say, and no one can figure out how it became that this secure, admin network was suddenly connected to the internet. And then I'm starting to kind of scan the network internally, which everyone's like, oh my God, I'm like, yeah, I want to see what's going on, who's connected, what's up. And suddenly I see a server that no one is put on the fancy Visio that's like sprawled over the wall. I'm like, where's this IP? Where's that server? It turns out no one knows. No one knows, and the server's got a web server, some FTP stuff on it, and some weird ports that when you connect to, it looks like it's a game server. Okay, so you start talking to the NOC operators and the guys from the night shift are coming in, and you kind of talk to them, go out for a cigarette, and you find out that they're playing, games, network games, at night because it's kind of dark and quiet and no one's watching, and they have their server. And they're like, where's the server? And the guy walks back in, and he's like, it's here. There's nothing here. They raised the floor, it's a raised floor, and there's a server down there. If that's not bad enough, all right, still remember, we're looking at a data breach. We're starting to dig down and see what's going on, and you see some switches in the floor and some stuff like that. And I get the networking engineer to identify the ports and this and that, and then you see, there's one switch here, and there's one switch over there, and that switch is like the small network that's internet. And there's a cable running between the switches. Someone needed to update the game server. So they just connected the patch cable between the switches. And suddenly, computers on the admin NOC are getting DHCP addresses from the internet. Phenomenal. So again, unless you actually touch things and map things and are able to say, yes, I know this IP address, it's connected to here, it's in that context, it's this VLAN, you don't know shit. Okay? So map things out. And make sure that you track the data. It's not politically incorrect to track your data. Okay? It's your data. You're responsible for it. And in most countries, I'm not a lawyer, you have the right as a company to track the data. Just as well as you're reading your employees' emails, okay, or scanning them at least for content, DLP, stuff like that. Just as well as you're doing that for web traffic, do it for voice. Ooh, big brother. Yeah, big brother. It's company connectivity. You don't have to listen to all those conversations, but you have a voice capability, all right? Just record everything, transcribe it, use like Dragon dictation or some free stuff to take all those voice conversations, turn them to text, and feed them back to your DLP. There you go, free product, all right? Someone's gonna come up with like $100,000 solution for that, but we did that for free for our customers. And you'll find stuff that violates policy, that will open your eyes in terms of what's going on in the company, because you're allowed to. Again, in most cases, I'm not a lawyer. Most American companies can do that. And by the way, remember to add honey. Honey is phenomenal. Okay? If you put data that you wrote that looks interesting, fish yourself, all right? And try to track it. Try to see where it ends up. Again, you'll find some very interesting things. Who touches that? Who moved it? Where? Okay? You'll find stuff in your company that you didn't know existed before. Couple of points to conclude. I talked about the social media mapping and stuff like that. I'm not connected to these guys, but they did some very, very cool work on Multigo. They have like an add-on package that you can use. They're called Packet Ninjas. The product is called SocialNet. I've used it a couple of times. Pretty cool. If you can't buy this, do it yourself. It's not rocket science. 2, voice or IP tapping is not really bad. Okay, I know I'm kind of going on a limb here, but you can do that, and you can still do that within legal constraints of certain countries. Again, you're not transcribing and listening to conversations. You're just running them through automated filters that detect problematic stuff. And then test some more. Because I'm going to quote, where's Nickerson? God damn it. Yeah. Quoting how do I define it? Quoting Nickerson, it's you can plan and prepare and think that you've got all your incident response stuff ready, but until the point that you get punched in the face, you have no idea what's going to happen. Okay? And then you go into the fight and you get punched in the face and you're like, what the fuck? What do I do now? It's like I'm bleeding and I'm kind of blurry and where's my procedure? So unless you want to get punched in the real world, punch yourself before or get someone to punch you that you can trust. Okay? Pen testers. And test yourself again. There are a lot of hints and guides and procedures and how to do this on the PTS website. Take note, learn, and comment. Time is up. If you have any questions, you can probably steal a minute or two. Otherwise, I'm still around.
Yeah, we got a couple of minutes.
Cool.
Anyone? Oh, come on.
Come on.
Seriously?
Drinks? I don't know.
You're all too shy to ask him? Okay.
I'm too scary.
Probably.
I don't bite if you don't want me.
Yeah, we got one. I will buy you a beer just because you're asking a question.
Going through printer stacks or through piles of paper with encrypted material sounds like a lot of fun and work.
Yes.
How often do you actually do that? Like waiting for several weeks to finally find your document?
Not necessarily several weeks. It's a lot of work. It's dirty work, but someone's got to do it. We're not doing this as an ongoing practice. It's usually part of an engagement. So I'm not, just for fun digging through crap and oh, there's my client's office. Let's see what kind of new shit they threw out. It's tedious work, but you know what? The funny thing is, just like any other task, you get really good at it. Once you just go into some mode. You know, you get into the zone, and you're like, this is crap, this is crap, this is crap. Oh, that's interesting. Let's put it there. Crap, crap, interesting. Straighten out the pages, scan, and it works. It's not pretty. It can smell bad, but
Yeah.
cheap labor. Yeah.
He's okay. We got another one.
Sure.
And how often were you looking for your encrypted, printed out pages and just found something better?
Oh, a lot of times, but usually the stuff that we encrypt is like really, really bad. But alongside it, you'll find it's hilarious. Yes. Although again, in most companies that you need to use this technique, they usually shred a lot of stuff or burn. So you're going through recycling, and recycling is usually cleaner, but in like a normal engagement, just a standard pen test, nothing fancy exfiltration, you just standard dumpster diving as part of your recon and information gathering, and you're golden. You've done the pen test before you even started it. You had one addition to the question, yeah?
Just wanted to tell about the tedious process of you can use the same printers or MFPs, just buy a big one. They have automated scanning OCR built in, and you just put the file on top. You just had to get it from dumpster diver, and you get the document afterwards.
Yep. Again, it's once you get the document out, it's decrypting it is fairly easy. More questions?
We got like 2 minutes.
2 minutes.
Anyone else?
I have to stand here for 2 minutes? Nothing.
I'm not
All
asking
right.
questions. God no. Okay. There you go.
Monster guy.
You just have to wait for people to like warm up.
warm up. I gave them like 45 minutes to warm up.
You told that you needed to send this file through VoIP to show that you can actually do it. But how did you send a command to your, I don't know, agent software?
I'm not talking about bidirectional. This is just kind of one way.
The one way.
There's another research that we did on botnet command control channels using DTMF over voice over IP. We had a talk at DEF CON a few months ago. Some interesting stuff. You can actually have bots dial out to like a conference call number. Again, free stuff that you can get. And basically listen to the conference call. And then you can walk into a public payphone, dial to that number, and using DTMF, issue commands and have full interaction. So you can tell them, you know, attack, I don't know, 5 for DDoS, 5. Enter IP address, 1, so you can have some interactive stuff as well.
Okay, that's it.
Okay.
Ian Amit, everyone.
Thank you.